Good morning, everyone. I will present in English. My Swedish is not still good to be able to do that. I will present the FATS project. FATS project is related to semi-solid, aluminum semi-solid casting, focusing fatigue properties and defects. I will focus my presentation today in fatigue strength of thick-walled aluminum, 7 silicon, 0.3 magnesium semi-solid castings. SSM is the abbreviation of semi-solid metal casting. I will use this during my presentation. You can see the people related to the project here. My name is George, as referred before. I'm from Jönköping University. I'm a PhD student. Volvo is also in the project. Volvo intend to produce some semi-solid casting components to use in trucks, mainly to reduce weight, and that way can increase load capacity, reduce emissions, and increase the fuel efficiency. And then we have Fueltech Sweden AB and Comptech AB as producing semi-solid castings, including the project. The project was financial by Vinnova. First summary, what I present today. First, a small background about what is the goal of FATS project. I will talk about a little bit of semi-solid metal casting. What is that? Many of you maybe didn't hear about. Results, I will present mechanical and fatigue properties that you can achieve in this type of materials. And conclusions. So, the goal of the project is to provide mechanical and fatigue properties for design semi-solid casting and applying components. There is not so much literature about fatigue properties of this type of castings. So there is a great need for fatigue and mechanical properties in order to apply in design of these components and also for numerical simulation of these components. So why industry is so interesting in this type of process? If you compare high pressure die casting with semi-solid die casting, semi-solid metal casting, high pressure die casting we use a superheated melt and then we inject at high speed in the die cavity. We have a turbulent flow that we can have air entrapment, for instance, as defects. In semi-solid casting, we start with a partial solid melt. So that means that we increase the viscosity, and when we inject that partial solid melt, higher viscosity than a superheated melt that is totally liquid, we produce like a laminar flow. And that way we can push out the air outside the die cavity. In that way we reduce the defects in terms of air entrapment. Besides of that, the shrinkage in the die cavity is reduced because some shrinkage already happened before, because we start with a partial solid material. And so the main advantage is that lower air entrapment and lower shrinkage related defects that is expected from this semi-solid casting. And also the advantage of high pressure die casting has high productivity. There is many of Rio casting process. I will describe the Rio metal process that we use in this project. You can see a sequence of images that show how the process works. If you, this is not the pointer, if you focus here in this image, the process starts when we're producing like a block, a solid block with the same chemical composition as the melt that we use, and we insert that block melt in the ladle with melt, like here. And one thing that is important to notice is that block has a lower temperature compared with the melt. The melt is a superheated melt, and we insert a block with a lower temperature. And that way, the goal of inserting that block that we call EEM is the enthalpy exchange material. is to reduce the temperature of melt until a semi-solid range, and also to stir the melt in order to produce a globular shape of the solid particles. That way we have a easily flow in the die cavity. So we do that, and then we just pour the slurry in the shot sleeve and inject in the die cavity. So in this project, semi-solid casting was produced with A356 aluminum alloy. You can see an image here of the casting. Here is the biscuit, the vent, and they are flowing. The piece that we are interested in is that one that is red wine color. In some of the castings, T5 and T6 heat treatments were applied, and then we performed tensile testing and 4-point bending fatigue tests that were performed in Volvo Group to know fatigue data, to have fatigue data and mechanical properties data. This casting presents 10 millimeters thickness and 20 millimeters wide in the section tested here. Here are the results. The table show mechanical properties, tensile testing from that we get. S-cast, T5 heat treated, and T6 heat treated. You can see that S-cast present higher elongation compared to other T5 and T6 heat treated, but lower mechanical properties. T5 is present a little bit higher mechanical properties, but not so much compared with S-cast, but much lower elongation or ductility. But T6 presents much higher in terms of mechanical properties, and the ductility loss related to S-cast is not so much. In the chart below, we can see fully reversed loading condition fatigue test. And we can see orange is the T6 heat-treated samples, blue is the T5 heat-treated samples, and gray ones is the S-cast samples. You can see that the T6 heat-treated samples perform better compared with T5 and S-cast. In order to have like a reference, we make some literature review. There is not so much in the literature that we can compare, but here we have two examples. Here I transport the results that I showed before to here. We have a T6 heat-treated samples, are orange, T5 in blue, and then we have at red another reo-casting process that we compare with other results that was T5 heat-treated, and you can see that the performance is similar to ours in terms of T5. And we also compare with low pressure die casting, T6 heat-treated at black. And you can see that the T6 heat-treated in this work perform a little bit better compared with low pressure die casting, and is close to T5. But sometimes it's not easy to compare because we don't know how the fatigue test was performed, and sometimes the samples are machined. In this work, the samples were not machined, was just the S-cast surface. So sometimes it's not easy to be comparable. But on the right picture, we can see a comparison between the T6 heat-treated sample in this work with the Roth alloy 6082 T6 that is sometimes used in structural parts of the truck. And you can see that the semi-solid casting can challenge that Roth alloy in terms of high fatigue properties. These tests were performed at load conditions R0, different than these ones here. And it was the same fatigue test performed and the same shape of the sample also in that one. So, in terms of conclusions, as expected, mechanical properties are superior for T6 initial condition compared with T5 and S-cast conditions. The T6 heat-treated castings present higher fatigue strength compared with T5 and S-cast initial conditions. Normally in literature you can find that are very close, but here in this work we find that there is differences and T6 perform better. And we can see, compared with the Roth alloy, semi-solid metal casting have potential to produce lightweight components for structural purposes. And it's finished. Yeah.
developing today, maybe I'm wrong, products in SSM. They're waiting for your results. And what you showed here is impressive results. That your alloy is actually performing better than conventional alloys and casting processes. Did you convince the designers at Volvo Group, for instance, to use your new material? And what are the limitations in this case, if not?
There is a prototype. I didn't present here because it's still ongoing test. It was produced in Comptech. And the first results show that was performing good. So
will they go further with designing in SSM in the future, do you think? Or?
Yes. I think so, because the project, there will be a new project coming, and we'll be focused on that, and a new prototype in another product will be produced.
Okay.
So they are thinking to other products to use this type of casting method.
Thank you.
Thank you. Very interesting. One of your goals are to create a new platform in this area. And you were talking about the knowledge. It isn't so known, this process. What about that?
It is known, the process. There is many of processes. I just present one of them, semi-solid casting. But I think it's still an ongoing process, mainly for fatigue testing of this type of components. Because this, I'm talking about thick-walled components. Normally this process is applied to thin-walled components. And thick-walled components we don't find so much. I present 10 millimeters, but we also perform in 20 millimeters. That is still ongoing. And compare with these results. That is new. Is the new thing. It's like.
What about the platform?
What do you mean with platform? Sorry.
One of your goals is to create a national platform in this area.
No, my goal is to create a fatigue data and mechanical properties. That is for the company to use as design purpose. Of course, later I will publish the results, and other people can have the results of that. But that always depends of the type of process that you use, and with the type of fatigue test that you use, that it can change. So many of times you cannot focus just in that data to make your calculations for your products. This is particularly for real material process and this type of thick walled components.
Thank you.